we're going to start just our review circles again. You guys would have learned this in geometry. Everybody should have their notes out. Alright, so in geometry, it was near the end of the year. You guys were near the end of the year when you guys were in the circles unit, graphing circles. Don't remember at all. Anyways, graphing circles is actually pretty simple. Your equation of a circle is going to look like this. Right? You're going to have parentheses, x minus h squared, and then plus, and then y minus k squared, parentheses equals r squared. This actually looks very similar to the distance formula, but without the square root. That's kind of where the distance formula came from, using this idea here. The hk, if you extract the h and the k from the expressions here, that's what creates the center, and then r is the radius. Notice that in the equation r is squared, so you have to remember to take the square root to find the radius. So all you have to do is pluck out those numbers, h and k, and find the center, and then take the square root of the number on the other side of the equal sign. You have everything you need to graph a circle. So let's look at this first one right here. For example number 1, we have this equation right here. I need to find the radius and the center of the circle, and then once we practice that, we'll actually practice how to physically graph it. So the center...
So we're keeping the sign in front of it, right?
No. Remember how when we're graphing anything that has parentheses, when you pull something out of parentheses, it doesn't matter what context. If you're pulling that out of parentheses, what happens to that number? It's the opposite sign. So it doesn't matter whether it's a circle, a parabola, square root, whatever. If you're pulling it out of a function, out of parentheses, or out of some symbol container, you guys will be changing the sign. So your center is going to be this number and this number, opposite signs written in the point.
1,
2. That's it. Very simple, very straightforward. And then the radius is just whatever this number is, square root is.
3.
That's it. Okay? What about the second one? What would my center be? It would be -1, -2. Because we take these two numbers right here, right? They're in order. So the x value is going to be in the parentheses of the x. And the y value is going to be in the parentheses of the y, just so you guys don't get that mixed up. And you change the sign, and then what would the radius be? 2. Take the square root of 4. Always, always, always take the square root of that number. Okay? Alright, what about number 3? No, where's the 1? I don't see a 1. -4 is 0. Same exact rule that we've been doing all along. If you don't see it inside of parentheses, it's a 0. Same thing as when we were graphing parabolas. So if there are no parentheses or no numbers inside of the parentheses, so they're essentially invisible, it's a 0. You're adding or subtracting 0 to get y by itself. So -4 is 0, and then what would the radius be?
5.
Okay. What about, for example, number 4? What would the center be? 0, 0. And the radius?
12.
Okay. So if you don't have parentheses, that means that you're adding or subtracting nothing to that particular variable. So that coefficient, not coefficient, sorry, that coordinate would be 0. Whatever. Alright, so now let's take that one step further. Let's do the exact same thing for these problems. We're still going to find the center and the radius, and we're actually going to graph them. Okay? So when I ask you to graph a circle, you need to know the center and you need to know the radius. You need those two things in order to graph it. So if you look at this one right here, what would my center be? My center would be -2, 3. And what would my radius be? 6. So with that information, graphing a circle is really easy. You're going to go to the center and draw a point. So -2, 1, 2, 3. Right there. Then all you do is you take the amount of the radius and you're going to count that much up, right, down, and left. Create 4 more points. Kind of like the directions, north, east, south, west. So I'm going to go up 3, draw a point, right 3, 1, 2, 3, draw a point, down 3, and then left 3. Well, make a circle. Do your best to sketch a circle. Don't make it like straight lines. Obviously not what a circle looks like. So you're going to draw those 4 points and then do your best to sketch a circle. It doesn't need to be perfect, but it should be circular in shape. Make those 4 points. And that's how you graph a circle. Very easy. Alright, what about the next one?
1, -3.
So the center would be 1, -3. And my radius?
2.
2. Again, make sure you square root the number at the end. I'm going to go to 1, -3. And then I'm going to go up and down and then out both directions by 2. And then I connect that. Try to make it a little bit neater than what I can do on board. Done? Alright, what's the center for the next one?
0,
-2, and my radius?
4.
So I go to 0, -2, and then I go out in all directions by 4. Alright, pretty simple stuff. So that's really all that's new for this lesson. So you need to know how to graph circles. Now when we get into the next page, we're actually solving them graphically. You need to graph a circle and a line on the same coordinate plane, and then a circle and a parabola on the same coordinate plane and see where they meet. So before we get there, I just want to talk about, so there are these two different systems. You have the circle and the line, and then the circle and the quadratic. So you guys will be working with these scenarios in your slides project. So the minimum number of solutions would be no intersections at all. So in this little empty space right here, I'm going to draw each of the scenarios. So this would be a scenario of a circle linear system where the circle and the line don't meet, so there are no intersections, no solutions. Okay? Then you could also have a scenario where they meet once. Imagine this looks like that. That would be an example of one solution for a circle linear system. You could also have the lines go through this way. So for a circle linear system, you could either have no solutions, one solution, or two solutions, just like we've seen for the past two different types. So up until now, to this point, all the different types of systems we've seen, the quadratic linear, the quadratic quadratic, and the circle linear, those have all had 0, 1, or 2 solutions. Okay? But for a circle quadratic, you can have no solutions, but the maximum is now 4 solutions instead of 2. So the circle quadratic one is unique. So let's draw, we're going to draw each of these 4 or 5 situations where you could have no solutions, 1 solution, 2 solutions, 3 solutions, or 4 solutions. So obviously this is what it would look like if you don't have any solutions, right? You have circle, quadratic, they don't touch. No solutions. Great. Or you could have them touch exactly once. And again, it doesn't have to look like this. It could be on the top or on the bottom. I'm just kind of giving one example. This would be an example of one solution. Okay? This would be an example of 2 solutions. Right? See how the quadratic hits it twice? Everybody should be drawing these illustrations. They're really going to help you for this slide project. Alright, so we have no solutions, 1 solution, 2 solutions. Then we can also have 3 solutions. This is what's unique. Alright, so for this one you can also have 3 solutions, which would look something like this. I'm going to draw one upward now. Well, that's the 4 example instead of so it looks like this. It touches, it goes down, touches once more, and then goes out again. So that's 3. And it looks like a V. Draw that more like a U. My artistic skills are limited on the board. So this would be an example of 3, where your quadratic not only touches the sides of the circle, it also goes down and touches the edge before it comes back up. So that's 3. Then we have one more solution, type of solution, where there are 4, where your quadratic looks like this. 1, 2, 3, 4. So the circle quadratic systems are unique. All the other types of systems we've talked about only have 3 possibilities. No solution, 1 solution, 2 solution. But for the quadratic system, there are 5. No solution, 1 solution, 2, 3, or 4. So that's what makes that particular type of system unique. So when you guys finish your slides project, you're going to have the scenarios for all of the different types of systems. You should have 3 for the linear quadratic, 3 for the quadratic quadratic, 3 for the circle linear, and then 5 for the circle quadratic. So I've laid that all out in an announcement on Blackboard where it's all listed by problem, problem 1, problem 2, problem 3. So I have everything what it should be in your actual slides project. So you can go reference that as you guys are finishing out these different types of scenarios. All right, before we actually get to the graphing bit, let's just look at this right here. Let's pretend I already have graphed it on the coordinate plane. I want you guys to identify what the solutions would be. So take a look at this one. First of all, how many solutions does this one have? There are two. So you need to write down 2 points. What are my solutions? I see 1, 2, 3, 1, 2. Okay, so 3, 3 would be 1.
-1, -3.
-1, -3. Guys, everything in this lesson is so simple. If you mess it up, it's going to be really disappointed. Okay? This is literally just looking at a graph, looking for the points of intersection of the line and the circle, and writing them down. Okay? Remember that the solution to a system is where each function intersects each other. So do I care about the x-intercepts here? Do I care about these right here, this point, this point, this point? No, because in a system, it's where the line crosses the circle. I don't care about the x-intercepts anymore. Or in this context. All right, how many solutions does this one have? None. You guys would write what?
No solution.
No solution. Because it's always a possibility. Okay. How many solutions does this one have? What is it? That's a little blurry. Oh, because this is the y-axis. It's a 3, 0. Right here. Okay. How many solutions does this one have?
3.
Okay. 1, 2, 3. Okay. So if it's already graphed for you, it's really easy to just look at it, visualize where they're crossing each other, write down those points. It should be really easy, really straightforward. So this entire first page, everybody should be on track. Yes? Really simple stuff. Anybody have any questions? Okay. So this is where you guys are actually going to be doing the work for this. You guys are going to have an equation of a circle, an equation of a line or a parabola. You guys are going to graph them and then tell me what the solutions are. Okay? Let's start. What? Alright. So, oh, and then at the very end we'll talk again. We'll recap about how to check to see if something is a solution. Alright, so the first thing you guys need to be able to do is identify which is which. Which one's a circle, which one's a line, which one's a quadratic. That's something you guys need to be able to do. So look at example number 1. What is the first equation going to give me if I graph it?
Circle.
Okay, so this one is a circle. What about the second equation?
Line.
That would give me a line. We call these family, like recognizing the family of a function. Just by looking at the equation, you need to be able to tell me what kind of shape it would create. Is it absolute value? Is it a linear equation? Is it quadratic? So it would create a parabola. That is something you guys need to be able to do just by looking at the equation. Alright, so let's graph the circle first. What would the center for the circle be?
0, 0.
Okay. And what would the radius be?
7.
Okay, so let's graph the circle. I'm going to go from the center, the origin. I'm going to go out by 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7. That's a big circle. Now, the graph of your circle does not need to be perfect. If you guys are going to have solutions on your circle, it will be one of the 4 points that you guys graph. So you don't have to worry about, like, oh, if I didn't make this out far enough, will I be able to see the intersection? When you guys graph a circle, it's only going to cross your circle at one of those exact points. So you don't have to worry about making it exactly the curve being perfect. All right, how do I graph that line? The second equation.
Up 7. 0, 7. For your y-intercept.
Okay, so your y-intercept is at 7.
And then 1 over 1.
And then your slope is 1. You're going to graph up, and I'm going to also mirror that to go down. Drawing every point that you can on the graph. All right. Once you have created both of these forms on your coordinate plane, you have the circle and the line both graphed. What would you write down as your solutions? Because you better not stop here. If I ask you to solve, you better actually tell me what the solutions are.
0, 7. And -7.
0, 7, and negative 7. Okay. Example number 2. What type of object or what type of equation is the first one? Yes. The first one is a quadratic. It will give me a parabola. What about the second one? A circle. So again, very important you guys are able to identify that. What's wrong with the first equation though? Or how did you know it's quadratic first of all? There's an x squared. Okay. What's wrong with it though? It needs to be y equals. So you guys will still see that, so make sure you're paying attention. This needs to be written in the form y equals, so I'm just going to really quickly subtract the x squared to the other side. Shift the 6 over, so it's in standard form. So shift the 6 over, subtract the x squared, so it goes in front. The circle will always be written in the appropriate form for you guys. You don't have to worry about fiddling with that. It's a little bit beyond regular algebra 2 for that to happen. All right, so let's graph the, which one do you want to graph first? Parabola? All right. So for the parabola, is this in standard form or vertex form? Okay. How do you find all the information you need about the vertex if you're using standard form? Negative b over 2a. What is b? 0. So I'm going to have negative 0 over negative 2, essentially. Well, what's 0 divided by anything? Okay. So the x, the first number for my vertex is 0, using the negative b over 2a. How do I find the y? Plug it in. So I plug 0 in here, I get negative 0 squared, which is 0, plus 6, which is 6. So for my parabola, the vertex is 0, 6. How do I graph the rest of it?
Negative 1, negative 3, negative 5.
1a, 3a, 5a, a being negative 1, as the equation says. So I would multiply 1, 3, and 5 times negative 1, which would give me negative 1, negative 3, negative 5 as my curve rule. So because it's negative, I'm going down. So I'm going to go down 1 over 1, first one, then down 3 over 1, and then down 5 over 1. Okay. Then you go and do the same on the left. And then you graph your parabola. Alright, again, this is not new. We've learned how to do this already. Alright, now we're going to graph the circle. Alright, what is the center of my circle? 0, 7. And what is the radius? 1. The square root of 1 is still 1. Teacher 1. Alright, so I'm going to go to 0, 7, 1, 2, 3, 4, 5, 6, 7. And my radius is teeny tiny, so you're just going to go up, down, left and right, out by 1. The teeny tiny circle, just like that. Itty bitty. Alright, so once you graph your teeny little circle up there, how many times does it intersect your parabola? Okay, so what's my solution? Did you see an x squared? See how the y is not squared here? So I understand this one has an x squared, right? But this one also has a y squared, because that's in parentheses squared. So basically, if you see one squared variable, and it's the x, that's quadratic. If you see two variables squared, the x and the y, that's a circle. If you see no squares, it's a y. Questions? Alright, I'm going to let you guys try the last two on your own. Number 3 and number 4. See if you can figure out those two, and then we'll do the last little section. Alright, for example number 3, let's see if you guys got work. So what are the two functions that I have? The one on the top, what kind of function is that? Is it parabola or classified as quadratic? The shape itself is called a parabola. The type of function is quadratic. What about the second one? Okay. What shape does a quadratic function make? A U, so I don't know why I was flipping through the quizzes and I saw an absolute value. That makes absolutely no sense. Okay, so quadratic is a U. It does not have straight sides. It is curved. So how would I graph the y equals? This one right here. This is in vertex form this time. So how would I find the vertex from vertex form? Okay. So for this one, what would my vertex be? You know your three. It's almost exactly the same way you find the center of the circle. If it's inside the parentheses, you pull that out. If this number is not in parentheses, you're still going to use it, you just don't change the sign. Very simple. Okay? So 2, -3, 1, 2, 1, 2, 3, right here. Then how do you find the sides of the curve? They're not straight. How do you find the curved side? Not x. 1a, 3a, 5a. You multiply 1, 3, and 5 times whatever a is. A being the number in the very front of the expression or the equation. So it's 1 here, so 1, 3, 5. You go up 1 over 1, up 3 over 1, and up 1, 2, 3, 4, 5 over 1. And then you repeat that on the left. Like this. So this is the parabola. I need you to correctly graph that on your paper. Okay? Then we're going to graph the circle. What is the center for my circle? 2, 6. My radius? 2. Make sure you take the square root of the number at the end. So I go to 2, 1, 2, 3, 4, 5, 6. I go out 2, up 2, out 2, down 2. What do you notice? This one is no solution. Alright, what about the next one? What is the top equation? What type? Linear. The bottom one? Okay, let's do the circle first. What is the center of the circle? 1, 0, and then the radius? Okay, so you guys should have 1, 0, and then a radius of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, then I have my line, which is y equals x. That means that the y-intercept is where? 0. And I have a slope of 1. So for this one, because it doesn't go exactly through these dots like I told you it usually will, almost always will, you guys are just going to estimate the closest exact point. Because again, it depends on how you draw the circle. So if you just kind of imagine, like if you were to draw better curve, just estimate what the nearest whole number point would be. So see, this one's pretty close to this point right here. 1, 2, 3, 4, 1, 2, 3. So I'd say 4, 4. Big, good bet. And then anytime you guys are estimating like this, if you take the 4, 4 and you plug it back in, right? And it makes sense. Like if I had accidentally chosen like 4, 3, would that make sense for this equation? Does 4 equal 3? No. So obviously because our equation is y equals x, that means each point that we pick, the x and the y value should be the same. So that's a little hint to guide you as you're estimating. But you can also like estimate and then plug it in to make sure it makes sense. So if you plug 4, 4 into the circle, you will also get the same answer, 4 equals 4. Or whatever, or 25 equals 25, whatever it is you plug it in. And then down here, it looks like the closest estimate would be -3, -3. Even though it's here, it was a little bit shy of how I drew my circle. I was a little bit shallow when I drew the curve. But -3, 3 again, that's the y equaling x, and if you plugged it in, you would get 25 equals 25, so it would work out for you. Okay? So if you guys run into that, it will be rare, but if you run into that, you can just do some kind of strategic guessing, and you can plug in to make sure that what you did was correct. Okay? Any questions on any of that? Random person. Everybody good? Okay. So the last thing we're going to talk about is revisiting this concept that we did at the end of the last lesson. We're going to revisit it again in the context of a circle. So let's say I give you a point. I want to know if it's a solution to the circle system. You guys are going to do the exact same thing we did last time. You're going to plug x and y into both equations and check for valid result. Basically meaning you want one side of the equal sign to be the same as the other side of the equal sign. So it's exactly the same as what we did last time. I have my point 5, 3. 5 is my x, 3 is my y. I'm going to take those numbers, I'm going to plug them into both equations one at a time, and make sure that whatever I get on the left is exactly the same as what I get on the right, because that would be required for the equation to be valid. So if I plug that into the first one, I would get 5 times 5 is 0. 0 squared plus negative 2 squared does it equal 4? Yes, because 0 squared is 0, and then negative 2 squared is 4, and 0 plus 4 is 4. So it works for the first equation. Everybody agree? Okay. Now we're going to test it on the second equation. I have 3 equals 2 times 5, which is 10 minus 5. Is that true? No. 3 is not equal to 10 minus 5. 3 is not equal to. So if it doesn't work for the second function, can that point be a solution to the entire system?
No.
Right. So again, just keep track from the point which one is x and which one is y, and plug them in to where they go in the equations and do some mental math. Alright, next one, I have x and I have y. I plug into the top equation, I get 36, 64. Does 36 plus 64 equal 100? Yes, it does. So it works for the first equation. Alright, now we have fractions here, but we can still make it work. Then we'll see if we can make it work. So we have 8 for the y, so we use 2/3 times 36, whatever that is, minus 16. So 2/3 times 36 is 24. Is 24 minus 16, 8. So does it work for the second equation? So is it a solution to the system as a whole? Yes. So just like we did last time, that's how you would approach it if you had circles in the mix. All right?